We are working on the topic of maritime. In particular, we established this project quite recently, but this is not a new topic for Eurisy. We are already working on maritime since 2014. We also had the opportunity of participating to the East Atlantic from Space workshop in 2019. The objective is to pass on the message that satellite applications bring an added value to end users' communities. This is true also in the case of space for maritime, so in the domain of maritime, and in particular for those communities of end users, they need to respond to specific challenges, maybe even in a timely manner. Might be for environmental issues, might be for pollution, might even be to optimize specific sectors, like, for instance, shipping. Next slide, please. I want to explain you better this through a couple of success stories that, as Cornel mentioned, they're also available on our website, in our database of success stories. Next slide, please. I will try to be very fast. So the first example that I would like to bring you is related to aquaculture, and in particular, this is a good practice that involves the Regional Fishery Committee of Lower Normandy. As you might know, Lower Normandy is one of the third largest shellfish producers in France, and in particular, mussels, for instance, represent about 30% of their production. But aqua farmers sometimes are facing some issues for what concerns shellfish yields. Because they have to face a variation of wind, water, temperature, sea currents, and this makes really complicated for them to make yield predictions or even to manage the stock of mussels. In addition to this, sometimes traditional methods, they tend to be costly or not very time efficient, and sometimes they also provide not very complete information to the aqua farmers. So for this reason, the regional committee partnered with IFREMER, which is the French Institute for Maritime Exploitation and of the sea, and they decided to release 6 geolocated drifting buoys to simulate larva drift in the area of Baie de Seine. To estimate the influence of water circulation on mussel larva dispersal, adding in particular this information, the location information, so the positioning of this larva drift, the drifting buoys, with the variation of those parameters that I just mentioned, so wind, water, temperature, and sea currents. The objective in particular was to understand how mussels respond to specific environmental factors, so how they do behave, and try to develop an accurate management procedure and how to protect the most important larval supply beds to maximize, to even better predict the shellfish yields, in particular the mussels one and other crustaceans ones. Next slide, please. The other stories instead that I would like to bring to your attention is on water monitoring, water surveillance, and in particular, it's the examples from the German Central Command for Maritime Emergencies. They always have to deal with marine accidents, and they have to do that in a very time-efficient way, in particular in the area of the North and Baltic Seas. When it comes to incidents, so marine incidents, it is important, especially when it's for oil spills, and the story is mainly about oil spills. The response and the reaction needs to be very fast and very specific and very much focused on the area where the oil spills happened, because oil spills are a threat not just to the environment and the marine ecosystem, but also if they get very close to the coast, also to the coastal economies, or in general to the ecosystem of the coast. So they need to receive, the Central Command needed to receive a very quick information, very precise information. So they decided to rely on CleanSeaNet. CleanSeaNet is an oil spill and vessel detection service provided by EMSA, and is the European Maritime Safety Agency, and is based on the ordering of SAR satellite images. And one of the solutions that usually are offered through CleanSeaNet is the identification of and tracing of oil pollution on the marine surface, as well as contributing to identification of the polluters, which is also really important, especially for the central command. In particular, the command receives a certain number of images per year, about 600 images per year. They usually are classified according to the dark spots and their resemblance of these dark spots in the area of the North and the Baltic Sea, with their resemblance to the oil spills. Combining this information with the vessel position, the central command is able to respond to the emergency and to identify the polluters. And everything happens in about an hour and a half, because after 30 minutes they receive this images. The CCME, so the central command, sends an aircraft to confirm the presence of the oil spills, and then they communicate to the HQ, so their headquarters, and then they start like the procedures to clean the area where the oil spills happened. The result, of course, is an improved surveillance capacity with more objective information and timely, efficient solutions. And in addition to this, they also have the opportunity, because Clean CNET is a European service, to even share with other countries information or even images to respond collectively when it is needed. Next slide, please. I invite you again, as also Cornel did, to visit our website, to get in touch with us, and to visit our social media accounts. Thank you, and I leave the floor to Remco.